for the second part of 2.3, we still are going to be looking at graphing a linear equation, but this time we're going to be looking at the x and y intercepts. Okay, so first, what are the x and y intercepts? Well, if I give you a line, let's just say that line there, the y-intercept we dealt with. This is where it crosses the y-axis. So our y-intercept here is right there. I would like to, when I ask you to identify x or y-intercept, think about it as a point. So that point there would be 0, 8. Okay? Now the x-intercept is the same thing, but it's on the x-axis. Okay? So now we're looking at this point right about there. Now that would be 3, 0. Okay, so there's our x and y intercept there. Okay, so look at a graph, just identify where it's crossing the axes. Okay, if I draw another line, okay, let's look at that line there again. Pretend that's a straight line. I'm sorry that's not exactly perfect there. For the x-intercept, let's start with, we're looking right about there. That would be at -4, 0. Y-intercept crosses at 2, so that would be 0, 2. Okay, now what I want you to notice, which is going to be important, is look at our two x-intercepts. -4, 0 and 3, 0. They do have something in common. The y-coordinate is both 0, and both of them are going to be 0. If you look at the y-intercepts, the x-coordinate is always going to be 0. Okay, that's going to be an important factor when you're given an equation to solve. Okay, so think about that as we move on a little bit. Now, I ask you, when I tell you to identify the x and y intercept, I want you to put it as a point, an ordered pair. That's the same thing if you are given instructions with this. Whenever you see x and y intercept, start thinking about it in the form of an ordered pair. So if you're given a word problem, write an equation for a line that is across the graph in a non-vertical manner but has peaks at all points and has an x-intercept of 8. Well, it's just giving you the x-intercept. It's telling you where on the x-axis it's crossing. It's crossing at 8. So all you know is what the x is. But if you think of it as a point, 8, 0, now you know x and y. More information you know, the better chance you have at solving the problem. Find the equation in point-slope form that has no peaks but some valleys and has a y-intercept of -3. So yes, we know y-intercept, if it's slope-intercept form, that's going to be your b value. Okay? But also think of it as an ordered pair. Y-intercept, 0, -3. Again, you know what your x and you know what your y is. That's going to be very important. We move on to 2.5 when we start writing out equations. The more information you know, the more you can plug in and have an easier time finding missing values. Now, moving on a little more, finding the x and y intercept. If you're given an equation, okay, 8x plus 3y equals 45. Okay, this is giving us an equation. And to find the x and y intercept, we're going to use that concept of the x-intercept always having 0 in for y and the y-intercept always having 0 in for x. Because if you remember that rule, the way you find the x and y intercept, to find the x-intercept, to plug 0 in for y, to find the y-intercept, to plug 0 in for x. You're plugging 0 in for the opposite variable that you're looking for. So let's first look at the x-intercept. Okay, and it says, to find the x-intercept, you plug 0 in for y. So I'm going to plug in 8x plus 3 times 0 equals 45. Now, what's nice about that is the math when you're plugging 0 in is usually kind of simple. 3 times 0 is going to be 0. Cancels out. So we have 8x equals 45. And if you just do some division, x equals 45 over 8. You can turn it into a decimal if you want. I'm going to leave mine as a fraction. Should not be able to be simplified. No, so that's on the at. Make sure you're writing it as an ordered pair. Okay. 45 over 8, 0 is my x-intercept. So it's not just x equals 45 over 8. I want it as an ordered pair. Now for the y-intercept, okay, we're going the other way with it. Plug 0 in for x. Y-intercept, plug 0 in for x. 8 times 0 plus 3y equals 45. And a lot of the same work happens. 8 times 0 is 0. That cancels out. Now if you divide 3 to both sides, you get to y by itself. Y equals, and that should be 15. Now again, don't leave it as y equals 15. Your y-intercept is 0, 15. Okay, so there's our y-intercept, there's our x-intercept. Now let's do one more example. Here we have y equals 5x minus 20. I'm going to start with the x-intercept again. Okay. Now again, x-intercept, you're plugging 0 in for y. This one's different. It's already in slope-intercept form. So the y-intercept should be a little easier to find. I'm still going to do the x-intercept first here since I have that on the board. I'll plug 0 in for y. Okay, I just want to make sure you watch your signs on here. Okay, you can't just divide by 5. I know you have 0 on one side, but you have to get things away from the variable. So I'm going to add 20 to both sides. 20 equals 5x. When you divide by 5, x equals 4. So 4, 0 is my x-intercept. For the y-intercept, same work, but this time I'm plugging 0 in for x. Y equals 5 times 0 minus 20. Now really, you should know just from slope-intercept form, negative 20 is going to be our y-intercept. Okay, just showing the work to solve it. That 5 cancels out because of the 0. And y equals negative 20. Our y-intercept, 0, negative 20. So there is finding with an x and y-intercept. Now why would you do this? The reason you find the x and y-intercept is because sometimes it's going to help you graph. Okay? I want you to kind of just imagine, get rid of this real quick. Okay? What if I gave you the equation, let's see here, 200 x plus 50y equals 70,000. Okay? So when you're dealing with some bigger numbers, if I need you to graph that equation, okay, you're not putting it in slope-intercept form. If we were put it in a slope-intercept form, I just want you to trust me, y equals 4x minus 1400. Okay, so think about what your y-intercept would look like. Okay, if you had to graph this, your y-intercept is negative 1400. Negative 1400 would be somewhere down here. Think of what your scale would be. Okay? You're not going to count by ones here because now our slope of 4x, we'd have to count up 4 over 1. But if we're graphing something like negative 1400, it'd be very hard to be accurate of being able to count up 4. Your tick marks would be so small, your intervals and scale would be so small, it'd be hard to count that much. But if you're just going to be able to find your x and y intercepts, okay, so we know our y-intercept is negative 14. Okay, our x-intercept, if I'm going to find my x-intercept, good to just show a little practice, 20x plus 50 times 0 equals 70,000. The 50,000 cancels out. Or sorry, the 50 cancels out. Okay, and if I'm going to do this, divide by 200, x equals, we end up with 350. Well, now we know where our x-intercept is also crossing. So we know negative 1400 is our y-intercept. Our x-intercept would be 350. And now we have our 2 points. So you didn't need to count up 4 over 1 on a very, very small scale. But you have your 2 points. You have your second one at 350, 0 here. Now you can just draw your line between the two. Okay, so that helps graphing if you have a scale that's very small because your y-intercept is a larger number and your slope is going to be a small number. 1400 compared to 4, there's a big difference there. find the X and Y intercepts might be an easier way to graph it.